My name is Prithvisha Nath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. This is week 2 for this course. We will solve questions and I suggest that you should try solving these problems along with me. So the first question. For a single particle, the necessary and sufficient conditions for equilibrium is or are the same. Can you tell me what is the answer to this question? So for a single particle, the necessary and sufficient conditions of equilibrium is same or different? Is it true or false? So we know that a particle is said to be in equilibrium if the resultant force acting on it is 0. So this is both necessary and sufficient condition for a particle. So this statement is true. Did you understand this?
Yes, ma'am.
Okay. So the next problem. The shortest member that needs to be added to the mechanism shown to convert it into a statically determinate truss is so here how many so 1 2 3 4 5 6 7 8 reaction forces 3 J is 1 2 3 4 5 6. So here m plus r is less than 2j. So how can you make it into statically determinate? You need to add a member such that the truss becomes statically determinate. We can see that it is a mechanism since it is m plus r is less than 2j. So how can you between which two points can you add the member? Can you tell like between which two points can you add the member so that it becomes statically determinate?
Ma'am, point A and B.
Between point A and B, there is a member already.
Then ma'am, C or D?
Yes. Yes. So,
Ma'am, I have a question.
yeah.
There is the value, R value is equal to 3. How can we get, ma'am?
Reaction, R value 3.
Yes, ma'am.
See, this is a roller joint. So, there is one force, one unknown, and this is a pin joint. So, there are two unknown,
Yes,
right?
ma'am. Yes, ma'am.
So, total 3.
Yes, ma'am.
Okay. So, is it clear to you now?
Yes, ma'am.
Okay. So, the shortest member, so it is CD, right? So, the next problem. So, how many members are there in this question? Can you tell me? And what is R and J? Just like the previous problem, can you tell me what should be M, R, and J?
Ma'am, J is 7. 3. J is 7, ma'am.
Uh, can you count it again?
Yes, ma'am. One is roller.
No, J is 8. 1,
Uh,
2, 3, 4,
yes, ma'am. Yes.
5, 6, 7, and this thing. In
Yes,
between
ma'am.
it
Yes, ma'am.
is 8. So R. So tell me what is R?
R. Ma'am, I don't know.
Just like the previous problem, R is R is equals to 3. Just like the previous problem, R is the reaction, unknown reaction, right?
Yes, ma'am.
So in this problem also it's a roller joint. So and this one is a pin joint. So
Yes,
total
ma'am.
unknown reaction is 3, right?
Yeah, ma'am.
And how many members are there? Can you tell me?
Members, ma'am.
1, 2,
1, 2, 3,
3,
4, 5, 6. 6, ma'am.
5,
7,
6,
7, 7.
7, 8, 9, 10, 11, 12, 13, 14,
And
right?
14. Yes, ma'am.
So M is 14. R plus J, sorry, M plus R. This is 17 and 2J is 16. So M plus R is greater than 2J. So what can you conclude from this? It is statically indeterminate, right?
Yes, ma'am.
So it is statically indeterminate and stable. Moving on to the next problem. A horizontal beam AB supported by a frictionless pin joint at A and a frictionless roller joint at B is loaded with loads as shown. The magnitude of the horizontal reaction in kilonewton at support B is. So can you please try solving this?
Yes, ma'am, I can. But at this time now, I'm don't doing because I'm not at home. But I am, ma'am, I am doing this. I know this type of question, so I can solve this problem.
Okay.
Okay.
So at A there is a pin joint and at B there is a roller support. So let this be RB, the reaction force at B, and at A there will be two components. Let this be RAY. So this is my coordinate system which I will be using, and this is RAX, where it is 30 kilonewton, 10 kilonewton, this is 40 kilonewton, this angle is 35 degrees. This distance is 10 meter. This distance is 6 meter.
Ma'am, this is 5 meter, not 6 meter.
Yeah. This is 10 meter. This is 5 meter.
Ma'am,
Yes.
can we skip this question?
No, I'll solve this question because others will be there who needs to understand.
Okay.
And this is 3 meter. So summation of force along the x-axis should be 0. So 40 cos 35 plus RAX equals 0. So RAX equals to minus 40 cos 35. So what is asked in this question? Magnitude of the horizontal reaction in kilonewton at support. So since this is a roller support, we know that it should be 0, right? So horizontal reaction at support B is 0. Now, next question. The magnitude of the horizontal reaction in kilonewton at support A. So I already found this out. That is this thing, RAX. That is minus 40 cos 35 degree that is equals to minus 32.77 kilonewton. So they have asked for the magnitude, so it will be, answer will be 32.77 kilonewton. The minus simply means that it is just in the direction opposite to the direction that we have considered. I have considered this force to be in the positive direction of the coordinate system, but it should be in the opposite direction. That is meant by this minus sign. In the question, they have asked for the magnitude. The next part of the question, the magnitude of the vertical reaction in kilonewton at support A. So, summation of force in the y direction similarly has to be 0. So, RAY minus of 40 sine 35 minus 10 minus 30 or we can just take the moment about this point B. Taking moment about B minus RAY. So if we take the counterclockwise direction as the positive, minus RAY into 10 plus 40 sine 35 into 6 plus 10 into 5 plus 30 into 3. Is this step clear?
Yes, ma'am.
Okay. So from here, I can find out the reaction, vertical component of reaction force at A. So RAY into 10 equals 40 sine 35 degree into 6 plus 10 into 5 plus 30 into 3. So RAY equals 24 sine 35 degree plus 76 kilonewton. Now they have asked the magnitude of the vertical reaction in kilonewton at support B. So we need to find out the reaction force at this support, right?
RAB, ma'am.
R this force.
Yes, ma'am. RB, sorry.
Yes. Now so the resultant of force in the y direction should be 0. I can write R day y this component of 40 kilonewton is acting in the negative negative y direction, so minus of 40 sine 35 minus 10 minus 30 plus RB. Did you understand why did I write this? 10, 30 in the negative direction
Yes, ma'am.
and RB we have considered in the upward direction.
Yes, ma'am.
So from here RA y plus RB is equal to 62.94. Now I have already found out RAY, so RB becomes 62.94 minus 27.76, that is equals to 35.18 kilonewton. Is there any doubt up till here?
No, ma'am.
So the next problem, a crimping tool is used to cut a thick wire as shown with all dimensions in millimeters. The thick wire at A gets cut when a vertical force of 125 Newton is applied at point G and H. At this instant, the inner angle theta between the arms of the tool is measured to be 25 degree. Assume the pin joints B, C, D, E and F to be well lubricated. What is the magnitude of force in Newton on pin D due to member DG? Can you try solving this question? Here is the question. Can you just try solving it? So the first part is you have to find out the force on pin D due to the member DG.
Ma'am, I didn't understood this question, ma'am. Can you solve this, ma'am?
Okay, let the others try. I will solve it.
Okay.
So I'll solve the question. It is given that the thick wire at A gets cut when a vertical force of 125 kilonewton is applied at point G and H. So here this force is 125 kilonewton at both these places, and this angle theta is 24 degree. Now we are asked to find the magnitude of force on pin D due to the member DG. We need to find the force here. So we will draw the free body diagram for this. Now this is the member ABD. This is B and C, and this is DG. This I can write as FAY. this force I'm assuming, the component of this force which is acting at D, I'm assuming it to be in the positive direction of the coordinate axis. So this is the coordinate axis that I'm assuming. This is FBY, this is FBX. Similarly, for point D, I'm assuming the reaction forces to be in the positive direction of the coordinate axis. Now, since for this point, for the member ABD, I have assumed forces at B to be in the positive direction of the coordinate axis. For this link BC, I have to consider it just in the opposite direction, because it is opposite. It is reaction force. It is acting in the opposite direction. So this is FBX and this is FBY, and for C again I'm assuming that the reaction forces are acting in the positive X and Y direction. This is FCX and this is FCY. And again, for the link ABD, I have considered the forces at point D to be in the positive direction. Similarly, I will consider it in the reverse direction at this point. FDX, this is FDY. This is FEY and this is FEX. Up till this point, is it clear?
Yes, ma'am.
So let us consider the member BC So moment about point C should be 0. So this implies that FBX should Now since fbx is 0, fcx is also 0. See, from this free body diagram, we can see that fbx will be 0 if we consider moment about c. Understood, right?
No, ma'am.
See, if for calculating moment, what we have to do, fbx into this distance, right? Let this be any arbitrary distance. Let this be any arbitrary distance a. Is there any other force which is contributing to the moment about c? No, right? Only fbx is contributing to the moment.
Yes, ma'am.
So this is equal to 0.
Yes, ma'am.
So a is not 0. So what we can say, fbx is 0, right?
Yes, ma'am.
From here we are getting that. Now we will consider the member ABD. Considering the member ABD, that is this member, the first. Now from the previous calculation we got fbx to be 0, right? This calculation.
Yes, ma'am.
So this is 0. Now what can we say? fdx is also 0 because this is a 3/4 member, right?
Yes, ma'am.
So from here we can say that fdx is also 0. So this fdx is also 0, right? Now we will apply moment about D. Now calculating moment about B. What can we write? Minus FAY into this distance is, what is the distance, can you tell me? Between point A and B, it's 20, right? So 20 plus FDY. It should be positive, or if I consider anti-clockwise movement as positive, so this should be positive or negative, can you tell me? The moment caused by f dy, should it be positive or negative?
Non-positive.
Yes, because this is anti-clockwise. Plus f dy into 48. This is equal to 0. So f ay equals to f dy into 48 by 20. Now we'll consider the last member, that is DEG. Considering the member DEG, I draw it once again. Here a force of 125 Newton acts. This is given as 9 millimeter. This distance is 220, and this angle, can you tell me what should be this angle from this figure? Can you tell me what should be this angle?
I'm 12 degree.
12 degrees, yes. 12 degrees. So this is point B, G, E. Now this is F, E, Y. This is F, E, X. F dx is 0, so I'm not writing it. And this is F dy. Now this is also a 3/4 member, so what can you say? Fex should be 0, right? Fex equals to 0. Now this is 0. Now we will consider moment about the point E. Calculating moment about E. So F dy into, can someone tell me what should be the distance? F dy into,
Can you show me the diagram, ma'am? Ma'am, 9.
Yeah. So f dy into 9 equals to
0, ma'am.
125. No, we should
How,
consider
how ma'am?
not 0. Okay, so I'm writing it like this.
Okay.
Uh, f dy to 9 minus 125 into. Now, can you tell me what should be this distance now? 125 into.
Show me diagram, ma'am. 220, ma'am.
No,
Ma'am, but there is shown
you
that.
need this distance, right?
Oh, yes, ma'am. Yes, ma'am. That is not given.
So this should be 220 cos 12 minus of 9 equals to 0. Did everyone understand this? Why is it like this?
Yes, ma'am.
I need this distance. Distance between these 2 points. Distance between these 2 points. So 220 cos 12 gives this total distance, right?
Yes, ma'am.
So I'm subtracting 9 from there.
Ma'am, how can I write in 9, ma'am?
9 is given here in the question, right? This is 9.
Okay.
So from here, f dy is 125 to 220 of cos 12 degree minus 9 divided by 9. So f dy equals to 2863.78 Newton. So what is the question? What do we need to calculate? We need to find out the magnitude of force at point D. So this is the force the magnitude of force at is 2863.78 Newton. Now what was the next question? What is the magnitude of the force that gets applied at point A? Now we already have this relation between f dy and fay. So this is the relation between f dy and fay. From this I can calculate fay. So fay equals to f dy divided by 20. I'll just substitute the value of f dy. So this is equal to 6873.07 Newton. Now, up till this point, is everything clear? Anyone has any doubt?
No, ma'am.
Okay. So next, we need to find out the magnitude of force on pin B due to link BC. Now, y should be the summation of force in y direction should be 0. So considering the link from BC, from this link BC, no, from ABT, from link ABT we can calculate. From ABT, from the link ABT, from the member ABT, so I can write FAY plus FAY plus FBY plus FDY equals to 0. Therefore, FDY equals to minus of FAY plus FDY. Now I already know FAY and FDY. I've calculated it. So I just need to substitute it. .6873.78 plus 6873.07. So this is minus of 9736.85 Newton. So this negative sign implies that it is in the opposite direction that we had assumed previously. So magnitude of force on pin B 9736.85 Newton. Is this clear?
Yes, ma'am.
Now, the next question is, what is the magnitude of force in Newton on pin E due to the applied load? So from this member DEG we can calculate the force at E. So FEY minus f dy minus 125 equals 0. F ey equals to 125 plus f dy. I have already calculated f dy. I'll just substitute here. F ey equals to 125 plus 2863.78, which is equal to 2988.78 Newton. Now, the next question, what is the mechanical advantage? So how do you calculate mechanical advantage? Mechanical advantage is given by output force divided by input force. Can someone tell me what is the output force? Which force is the output force in this figure, in this problem? Can you tell me which one should be the output force?
Ma'am, H.
The output force. The force at H is input force. We are applying force there. So it is input force. Which one should be the output force? The force at A, right? It is used to cut the wire.
Yes, ma'am. Yeah.
So, so the output force should be FAY, right? Therefore, this 6873.07 divided by the input force, which is 125. This comes out to be 54.98. It is asked to round off to the nearest integer, so it should be 55. So is this clear?
Yes, ma'am.
So I'll just go through the questions once more. So for the first question, it is asked for a single particle, the necessary and sufficient condition for equilibrium is or are the same. So we know that for a particle to be in equilibrium, the resultant force acting on it should be 0. So this is both the necessary and sufficient condition in case of a particle. So this statement is true. Is there any doubt? Anyone has any doubt for this question?
No, ma'am.
So the next problem, we need to find the shortest member that needs to be added to the mechanism shown to convert it into a statically determinate truss. So we can see there are 8 members in this figure, and the reaction forces, unknown reaction forces are 3. The truss is supported by a pin joint and a roller support. So the reaction forces, unknown reaction forces are 3, and the total number of joints are 6. So M plus R is less than 2J. So it is a mechanism as mentioned in the question. Now, where should we add the member? So it is definitely between point C and D. For the next problem, again there is a truss assembly. Like the previous problem, here the unknown reactions are 3 and total number of members present is 14 and the number of joints are 8. So M plus R is greater than 2J. So it is statically indeterminate. Now this is a horizontal beam which is supported by a frictionless pin joint at A and a frictionless roller support at point B. So I have drawn the free body diagram. We are asked to find the magnitude of the horizontal reaction at the support B. So since this is a roller support, we know that we can see that the horizontal reaction at support B should be 0. And the total force in the x direction should be 0. So 40 cos 35 plus RAX is equals to 0. From there I am getting the horizontal reaction force at A. So this is the next problem, the magnitude of the horizontal reaction at A. So I got this to be minus 32.77, which means the original force is acting in the opposite direction of the assumed direction. The next question is the magnitude of the vertical reaction at support B. Now what we are doing, we are calculating moment about B. So I have assumed the anti-clockwise direction to be positive. So RAY is having a positive moment about B. So minus RAY into 10. The component of this force is causing a positive moment, that is a clockwise moment. about this point B, so it is positive. Similarly, the forces 10 and 30 are also the 40 is causing anti-clockwise moment about B, and 10 and 30 is also causing anti-clockwise moment about B. So these forces are positive, causing positive moment. So from here, I can calculate RAY, that is the vertical reaction at support A. Now, the magnitude of the vertical reaction at support B. Now, as it can be seen from the free body direction, RAY is acting in the positive direction, 10 and 30 is acting in the negative direction, and component of 40 is also acting in the negative direction. So from here, I get the value of RB, that is the reaction force at support B. Now this is the problem of the crimping tool. So a thick wire at A gets cut when a vertical force of 125 Newton is applied at point G and H. At this particular instant, the angle is 24 degree. We are asked to find the magnitude of force on point D due to member DG. So I have drawn the free body diagram on the members, and this is my this is the positive X and Y direction. Now for the member ABD, I have assumed the reaction forces at B in the positive direction of the considered in the positive direction of the coordinate system. So I have to take the reaction force at the on link BC in the reverse direction. Is there any doubt regarding this free body diagram? Anyone has any doubt regarding this free body diagram? So is there any doubt regarding this free body diagram?
अरे यार फोन में क्या हुआ यार, फोन अपने आप चल रहा है. नो मैम.
Okay. Next, we need to find out the magnitude of force that gets applied at point A. So we are considering this member BC. From BC we can see, and if we calculate moment about C, we will see that Bx is becoming 0. So Fcx is also 0. Now we are considering the next member ABD. From the previous member we got Bx to be 0. So In ABD, dx is becoming 0. F dx is also becoming 0. Now, we are calculating moment about B. So, FAY is causing a positive moment about B, so it is negative. I am considering anticlockwise moment to be positive. And FDY is causing a positive moment. So, this is the relation between FAY and FDY. Now, I am considering the next member DEG. From here, I can see that FEX should be 0 since it's a 3/4 member. Now I am calculating moment about DE. So FDY comes out to be 2860.78 Newton. So this is the magnitude of force that acts at point B. Now from this earlier relation that we found out, we can calculate the force that is acting at A. Now we have to find out the force which is acting on pin B due to the link BC. Now from member ABD, we can find out the force at B. We know that Fdx is 0, so the force which is acting at B is only Fdy. So if we can find out Fby, we will know the force which is acting at point B. So we are just substituting Fay and Fdy, which we have calculated earlier. And in the next problem, what is asked, find the magnitude of force on pin E. Similarly, we are considering this member DEG, and from there we found out that FEX should be 0 because it's a 3/4 member. Now FEY comes out to be 2988.78 Newton. And finally we have to find out mechanical advantage, which is equal to output force by input force. Output force is the force obtained at A, and the input force is 125 Newton, which is applied. This is approximately 55. So is there any doubt in the problems that we discussed today?
No, ma'am. I have no doubt, ma'am.
Okay. So anyone else have doubts regarding the problems that we discussed today? Okay, then we will stop here.